Welcome back. Let us continue with remaining arithmetic operators and unary operators. Let us see an example of minus operator. In this example, I1 is of int type, I2 is of int type, F1 is of float type, and D1 is of double type. Now this expression I1 minus I2, I1 is int, I2 is int, so the result will be an int. 12 minus 5 equals to 7. So this will print 7. Now this expression includes I1 and F1. I1 is int, F1 is float, so the result will be float. So we need a float variable to store the result, and the value will be 12 minus 5.0, that will be 7. And because this is a floating point number, so we need to include decimal. Third one, I1 is 12, D1 is 5.0. Because this expression includes an int and a double data type, so the result will be double, the highest of the two data types, and the value will be 12 minus 5.0, that will be 7.0. Let us check the result. So 7, 7.0, 7.0. 7, 7.0, 7.0. Next is multiplication operator. Over here, again we have 4 variables. Now let us first see this expression, I1 into I2, both are int. So what compiler will do over here? Compiler will add a int typecast because both the data types are int. It is same as writing this one, I1 into I2. So we need an int data type to store the result. In this case, 5 into 10 is 50, which will be stored in an int type memory. 50 res1. Again, second expression, I1 into F1. I1 is of int type, F1 is of float type. So whatever is the result, it will be stored in a float data type because float type is greater than int type. So the result will always be float. So either we can use a float type or double type to store this result. In this case, we have used float type. Res2 and 15.5 multiplied by 5 will be 77.5. Third expression, I2 into D1. I2 is 10, D1 is 20.5. So the result will be stored in a double type. Res3, 10 multiplied by 20.5 will be 205.0. Let us verify the results. So res1 is 50, res2 is 77.5, res3 is 205.0. Let me correct it over here, 205.0. Let us move ahead. Byte B1 is 20, byte B2 is 2. Now this expression contains 2 bytes, B1 multiplied by B2. So by default, compiler will typecast it to int, but we are storing it in a byte type, so we'll need to explicitly cast it to a byte type. So the result will be 20 into 240. So the result is 40. Now let us see this example. I1, I2. Reassignment means we are assigning another value to the variable I1. So over here in this case, instead of 5, we are using another value. It is 1 0 0 0 0 0 0 0, and in I2 it's 5000. And this expression I1 into I2, what compiler is doing over here is, because I1 and I2 are both int type, so it is typecasting it to int I1 into I2. So this is the expression, and res1 is of int type, this is of int type. And if we multiply I1 into I2, this value will be outside int range. But because compiler is doing implicit casting, so compiler will try to ignore the extra leftmost bits. So in this case, result will be different than the expected result. Let us check that result. So the result is this one. Next comes division operator. Here I1 is of int type, I2 is of int type, F1 is of float type, D1 is of double type. Now let's check this expression. I1 divided by I2, int is divided by int, result will always be an int, and it will be maximum number of time you can divide without using any decimal point. So let's see. Over here we have 12 to divide by 5, 2 times is 10. This is known as remainder, but we are interested in this result. This 2 will be the result of dividing I1 by I2. Now what happens if we include decimal point number? For example, this expression I1 divided by F1, F1 is of float type. So one operand is of integer type, another operand is of float type. So result will always be of float type. So we are using a float memory to store the result over here. But what will be the result? If you are dividing by a floating point number, we will use the decimal point. Let's see, 5, 2 times 10, remainder is 2. Then I want to move ahead, so I'll use decimal point, I have to add 0. 4 times is 20, the remainder is 0. The result will be 2.4 in this case. Similarly with double, I1 is of integer type, D1 is of double type, so the result will always be of double type, and again in this case I will get 2.4. So let us now run this example. So first I got 2, second time I got 2.4, and third time I also got 2.4. Finally we'll see modulo operator. Let us see this example. I1 is of int type, I2 is of int type, result will always be of int type. So let's see, 5, 12, 2 times 10. Without using decimal, this is the remainder. Now there is some difference between the division operator and modulo operator in case of decimal point number. Let us check this difference. So I1 is of int type, F1 is of float type, and we are using a modulo operator. Result will always be a float type. So let us now check 5.0, 12, 2 times 10, remainder is 2. Now we'll not move ahead and will not add decimal to this side. So the result will be this one, and because we are using a decimal point, so the result will be expressed in a decimal point. So 2.0 will be the result in this case. When we were checking the division, we moved ahead. So what we did for division was something like this: 5.0, 12, 2, 10, 2. We added a decimal point over here, 20, 4, 20, 0. So this was not a remainder. Remainder is always 2.0. And this was the answer of division. Let us go back to the slides. Next set of operators are called unary operators. Unary means these operators work on one operand only. Unary plus indicates positive value. By default, numbers are always positive. Unary minus operator, this negates an expression or value. Unary plus plus is increment operator. It increments a value by 1. Unary minus minus is decrement operator. It decrements a value by 1. And the exclamation sign is known as logical complement operator. It inverts true to false and false to true, and it works on Boolean operands only. Let us see some examples. In this example, variable I1 equals to plus 10. Plus sign is not mandatory over here because numbers are by default positive. Over here I2 is 10, which is plus 10. For I3, this unary minus sign is negating a value. And for I4, this unary minus sign is negating an expression, which is I1 plus I2. So what happens in this case? This will become minus I1. The value of I1 is 10 plus 10, which is 10. Then binary plus, and then value of I2 is 10. this expression will result into 20 and the result will be minus 20. So over here this one will print I1, value of I1, which is plus 10. So when printing, the plus sign is not shown. I2, value of I2, which is 10. So this will print as 10. I3, the value of I3 is minus 100, so it will print minus 100. And finally the value of I4 will be printed as minus 20. Let us now verify the output. Right click, run as Java application. So the first output is 10, I1 equals to 10, I2 equals to 10, I3 equals to minus 100, and I4 equals to minus 20. Note that in the println statement we have used an expression. Over here this is a binary plus, and the left operand is of a string type and the right operand is of integer type. So over here the plus operator will behave as a concatenation operator. And what concatenation operator does? It will simply combine these two values. That is why in the output you see I1 space equals to space and the value of I1, which is plus 10, plus sign is not included. So that is why we see this output. So I1 equals to 10. Let us now see increment and decrement operators. Increment and decrement operators increase and decrease a value stored in a number variable by 1. For example, these statements var equals to var plus 1 and var plus plus are doing the same thing, incrementing the value of var by 1. The increment and decrement operators can be placed before or after an operand. When the operator is placed before the operand, it is called pre. For example, this is pre-increment operator and this is pre-decrement operator. Same thing with post. If we are using operator sign after the variable name or after the operand, it is known as post-increment operator or post-decrement operator. Let us now understand the difference between pre and post. So the definition of pre-increment or pre-decrement states that when the operator is placed before an operand, the variable will be incremented or decremented by 1 in the memory, and then the new value is used in the expression in which it appears. Let us now first understand what does this mean by looking at this example. So in this example, we have a variable a, which is of integer type. Its name is a, and the initial value is 25. Now let us check this statement, system.out.println plus a. Now this is a pre-increment operator. Now by the definition of pre-increment, it says that the variable will be incremented or decremented by 1 in the memory. So let us first make the increment in the memory. Increment the value by 1, 26. Now use the new value in the expression. Now in this expression, we will use 26. So the system.out.println will print 26 in this case. The second statement, system.out.println minus a. This is pre-decrement operator. Now again, first make the changes in the memory. 26 will become 25 because it's a decrement operator. So decrease the value by 1. Now use this value in the expression 25. So this system.out.println statement will print 25. Now let us see post-increment or post-decrement. When the operator is placed after an operand, old value of the variable will be used in the expression where it appears, and then the variable will be incremented or decremented by 1 in the memory. So now what does this mean? Let us see the similar example. In this case we have an integer variable. It is of integer type. Its name is b. Initial value is 25. Now let us see this statement. System.out.println b++. Now this is a post-increment operator. So by the definition of post-increment or post-decrement, use the value of the variable first. Current value is 25. So use it in the expression. Then go and make changes in the memory. So increment it by 1. B will become 26. But system.out.println will print 25. Another statement, system.out.println b minus minus. Again this is post-decrement operator. So first use the current value that is in the memory. So current value is 26. And go and make changes in the memory. So decrement it by 1. B will become 25. but 26 will get printed in this case. So the final value of A and B is same, which is 25. This happened because we first incremented the value by 1 and then decremented in both the cases, but the result of statements are different depending on the pre or post operators. Let us see some examples of increment and decrement operators in Eclipse. So in this example, we have two variables I, the value of I is 10, and the variable j, value of j is 5. Now we have this expression I plus plus. We are not using it in any other equation. So simply this means increase the value of I by 1. So I will become 11. And this is also a simple expression. It says decrement the value of j by 1. J will become 4. At this point, if we use system.out.println to print the values of I and j, we will get 11 and 4. Now let us now consider this expression I plus 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 minus minus j. So the expression is I plus 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 minus minus j, and we are assigning it to a variable named res. Now this is post increment operator, which means use the value of I first. We'll use the value as 11 and then go and change the value in the memory. 11 will become 12. Binary plus sign and then minus minus j. This is a pre-decrement operator, and this means first decrease the value of j by 1 in the memory. J will become 3, and now then use it in the expression. So 11 plus 3 equals to 14. So res will have 14, and at this time I will be 12 and j will be 3. So res is 14, I is 12 and j is 3. So let us verify this output. Right click, run as Java application. First time I equals to 11, j equals to 4, res equals to 14, I equals to 12 and j equals to 3. We'll see more interesting examples of increment and decrement later when we learn operator precedence. Let us now see an example of logical complement operator. This is very simple example. We have a flag variable that is Boolean type, and initially the value of flag is true. Now in the first println statement, we are using logical complement operator and the Boolean variable flag, which will turn it into not, and the Boolean variable's value, which is true and not true, will become false. In the second expression, not flag equals to, this expression will become logical complement operator, value of flag is true, this will become not true, will become false, which will become true. So the output of this statement will be false, and this will print true. Let us now verify this. First it is printing false, on the second line it is printing true. So far we have covered arithmetic operators and unary operators. In the next lecture we will learn about relational operators, logical operators and assignment operators. Till then, happy coding.